And we're back. The lesson right now is going to be on antiderivatives. And the antiderivative is a function whose derivative is a given function. Now that's got too many words in it, so let's break it down a little bit. Suppose that we have a function y, and I'm going to define y by saying y is the derivative of x cubed minus 2x. Now we know how to take derivatives, and so I'll just go ahead and take the derivative of x cubed minus 2x, and I get 3x squared minus 2 using just the polynomial derivative rules. And so, of course, this is y is equal to 3x squared minus 2. Now an antiderivative of y would be another function, and if I differentiate that function, I would get y. I want to introduce a notation. Notation is a little complex, but notation is very important because it gives us a concise way to write about complex ideas. So here's a notation for the antiderivative. That is an elongated s. It's an integral sign. The integral of y dx is a symbol for the antiderivative of y. Now I could write that in this particular case, since y is 3x squared minus 2, the antiderivative of 3x squared minus 2. And what is that? That's equal to another expression, and if I differentiate this expression, I get y back. That is, I get 3x squared minus 2. The derivative of this expression, we'll discover what it is in just a second. The derivative of that expression gives me y. And y is what? Y is 3x squared minus 2. So to finish this problem, we just need to find a function, it goes in here, whose derivative is 3x squared minus 2. That'll be what goes in this box up here also, because that function would be an antiderivative of y. It would be an antiderivative of 3x squared minus 2. Now, do we know any function whose derivative would be 3x squared minus 2? Well, if you look to the first line of this lesson, we saw that the derivative of x cubed minus 2x is exactly 3x squared minus 2. So in this box, if I put x cubed minus 2x, that will be an antiderivative of 3x squared minus 2. Why? Because if I take the derivative of x cubed minus 2x, I'm going to get, and you can differentiate and make sure that this is all right, I'm going to get 3x squared minus 2. And we might just note here also that the antiderivative of 3x squared minus 2 dx, which reminds me I forgot a little dx here for you. In the most general sense is equal to x cubed minus 2x plus an arbitrary constant. Why is that? Because if I take the derivative of x cubed minus 2x plus any constant, 10, 20, 30, a million, negative 20 billion, this can be any constant, then that's going to be the derivative of x cubed dx minus the derivative of 2x dx plus the derivative of the constant dx, and that's equal to, well, we know how to take derivatives, especially of the polynomial functions, and so take the derivative of the first term, 3x squared, minus the derivative of the second term, 2, plus the derivative of the third term. It's a constant. So what's the rate of change of a constant? Well, it's 0. If it was changing, it wouldn't be a constant. So that's a 0. And so you see I'm going to get 3x squared minus 2 for the derivative. And that means that the antiderivative of 3x squared minus 2 must include this arbitrary constant. All right. Next, we're going to do some practice.